This program got started as a partnership between the University of Washington and Google in an attempt to help students start thinking about new ways of computation.
This is not vocational ed. The fact is the great computer science programs, Washington, Stanford, Berkeley, MIT, Carnegie Mellon, we're teaching our students skills that they're going to need for a lifetime.
This is a combination of using Google hardware for most of the CPU horsepower. IBM is also contributing hardware for management services, and we do this then all using open source technology.
For many decades now, people are going to be solving these large-scale data-intensive problems, and they're going to be solving them on clusters, ever larger clusters.
One of the great things about having the cluster available in the classroom is that students were able to iterate on their ideas relatively quickly.
And we want that same simplicity and elegance to be applicable when they want to be able to run their jobs across thousands of machines.
If you look around at computing companies, Google, Microsoft, Yahoo, IBM, they're all computing in roughly this way.
And so what we're trying to do with this program is teach students how to design software and interact with these clusters so they can address the needs of users and business going forward.
That's the motivation from our point of view. It's produce students who can tackle today's problems.
During the process of interviewing hundreds of college students, you start to realize that even the most talented, brightest students sometimes have trouble thinking about problems on the scale of 1,000 machines or terabytes of data. So I started to think about how we could work with universities to better prepare students to face these challenges when they graduate.
What we've got today is a whole new approach to problem solving, which is analyzing massive amounts of data on large-scale clusters. It's no longer a niche. It's something that's in every walk of life. Whether you're doing credit card fraud detection or web analysis, you're using that approach.
All across the industry, I think this is going to be beneficial to the students in their careers and also to make sure that this next generation platform becomes widespread and adopted.
For me personally, I think the biggest challenge for teaching this course was just that it's never been done before. Distributed computing is relatively new in the undergraduate curriculum.
My name is Slava Chernyak. I am a University of Washington senior in the computer science department. My project was to create a simulation of the collision between the Andromeda and Milky Way galaxies. There's a lot of computation required to simulate such a collision.
It is the nature of mind to create.
I'm Brian Steadman. I'm a senior at the Department of Computer Science at the University of Washington. You have a lot more computational power, you have a lot more data, and it's a lot more real to what's currently out there in the industry.
IBM has developed a plugin for the Eclipse platform that all of our students use that let them have access to a cluster located anywhere in the world, just as if it were a machine in this building.
My name is Juliette Schwarz, and I am a student at the University of Washington, senior majoring in computer science. My project, which was called GeoZet, was a website which took thousands and thousands of news articles, figured out the location that these articles were talking about, and then placed them on a Google map.
Working on a single computer, it might have taken them days or weeks in order to find the patterns that they were looking for. But with having the cluster available, they could try out an idea, experiment with it, and decide it doesn't work, and then move on into a different direction within a matter of minutes.
The real difference this course made was it allowed us to use technology that businesses are using right now.
We've got ideas.
More and more of our students are going to be taking this course. Essentially, everybody wants to take it because they realize it's something they've got to know. They've got to know for the future.
Having this course really gives me an edge on my competition, and it's absolutely fascinating.
Google's expertise is in building and maintaining these large-scale systems, but we desperately need universities like the University of Washington and other institutions to start thinking about how to impart these skills onto students earlier in the curriculum.
Now we're looking at a situation where Google and IBM teaming together are going to deploy data centers that the entire national university community is going to have available to it for research and education. What began as one engineer's 20% project is now something that's going to affect the whole nation. It's utterly remarkable what you can do.
Cloud computing, baby.